A very good afternoon, everyone. Yeah, today I would like to talk about a simple linear regression algorithm. Yeah. So this algorithm will be comes under machine learning supervised technique. So here SLR supervised, simple linear regression will be supervised learning technique. Let me talk about this particular technique subsequently. What supposingly, right? Yeah, about supervised learning process, I would like to talk about how supervised learning process flow will happen and what are the supervised learning techniques are there. And about among all the supervised learning techniques, I would like to talk about simple linear regression as part of a supervised learning approach. Yeah. Firstly, I would like to talk about what exactly supervised learning technique is. SL indicates supervised learning is the process of an algorithm learning from the training data set. Yeah, supervised is nothing but basically we will be distinguish unsupervised from the supervised based on the data set. That's the reason a training data set, if a training data set you would like to train a model, a data set should have a label. A data set will have a label. Isn't it? Let me take certain things. Yeah. So here I wanted to classify a student whether he is eligible for the placement or not, isn't it? So what you would like to take is SSC marks, MSET marks, aggregate percentage till 3-2, and extracurriculum activities. If the student has these features, so the student is an entity. Usually this is the row about a first student, 0th student. So his marks will be 75% and MSET rank will be 2000 and aggregate percentage will be 65 and extracurriculum activities out of 4 will be our extracurriculum activities. Then I will be able to label this particular label as 1. He is an eligible. 1 is an eligible. Similarly, a second student is having 85% is a feature and MSET rank will be 2300 and Academic, aggregate percentage will be 76. Extracurricular activity will be 5. Then also he is going to be eligible for the placement. This is called as a label. This is called as a label. So if the student has SSC marks will be 55, MSET rank will be 45,000, isn't it? And aggregate percentage will be 49. His extracurricular activities will be 5, but still I'm going to make this student as not eligible for the placements. So in this way, 1, 0, this label, this label column will be give you whether you are applying a supervised technique or maybe unsupervised technique, isn't it? So supervised learning is a process of an algorithm learning from the training data set. Training data set has a label, then this particular data set can be trained for your model. If the data set does not have this particular label column, then it will be applicable using unsupervised learning approach called as a K-means algorithm. Right? I hope you understand what exactly a supervised learning technique is. So such a technique I am going to discuss about, which is a simple linear regression model. This is the model. Okay. Right. Yeah. So simple supervised learning approach will be treated as a teacher, which is to be supervising for learning process. So here is that the data set you have made such a way that where the label column will be helpful to supervise for learning a particular process using an algorithm, right? Okay. So in supervised learning algorithm, any algorithm, it can be supervised learning algorithm, it can be a logistic regression algorithm, it can be decision tree, it can be Navi based, it can be support vector machine. So these are the algorithms. Any algorithm you take, a supervised learning algorithm, we will be generalized a learning process with the help of y is equal to f of x. Y will be a target label. Y will be a target label to be predicted. F of x will be input features. So a simple example, for example, f of x will be it can be a x1, it can be a it can be x2, it can be x3. Number of features can be anything. Let us suppose x1 to predict whether the person is suffering from corona or not. X1 will be fever. X1 will be a fever, is a feature of a patient. X2 will be cough. X3 will be a breathing problem. So fever is a one feature, cough is a one feature, breathing is a one feature. Based on these features, whether y is either 1 or 0, one means he is suffering from COVID, suffering from corona. 0 means he is not suffering from corona. So likewise, in order to apply hospitality data set to predict COVID, which is corona, then this is going to become a input features for you. So in this way, f of x will be generalized input features, y will be an output target label. So in this process, let me take an example and I'll explain to you how y is equal to x, f of x will become a function, generalized function, right? So here, y is equal to f of x is the process of an algorithm learning, which is a mapping function from an input variable x to the output variable y, right? So input variables are x, output variables are y. Y is a target variable, x will be an input function. Right. Now, so what is the process this supervised learning process would follow? Basically, you might have heard training and testing of model is going to happen if we apply supervised learning approach. So firstly, we have to take historical data. It can be a student data, it can be a hospitality data, it can be e-commerce data, isn't it? Firstly, to apply a supervised learning technique, we should have a historical data, okay? If you have a historical data, we have to gather some sample from the historical data, because see, if you have a blood, you might have a 7-8 liters of blood in our body, but to test whether you have a diabetic or not, we will take a sample blood. We are not going to take an entire data. So historical data can be 100%, in which random sample will be extracted, okay? This random sample is going to become a, 80% of the data will be considered as a training data, isn't it? Okay. Afterwards, we are going to apply this training data set to the machine learning, isn't it? So this machine learning technique can be called as, now here we are talking about simple linear regression, right? Okay. Statistical models we are going to apply, and this entire the process will be happen. This entire the process will be happen during training stage. During training stage. During training stage. So afterwards, in this random sample data, 20% of the data will be, it is not fixed. It can be a 50, it can be a 50, it can be 70, it can be a 30. So that's up to the scholar or maybe researcher what he would like to test for a model accuracy. So here, so this process will be a testing data. So 20% of data will be given for the testing a model, and we are going to predict how far our model is going to be accurate. So this is a validation of a model. This is the abstract nature of the way how a supervised learning process would be happen. Probably earlier authors might have explained to you how supervised learning approach will be followed in order to test an accuracy of a particular model. So let me go with a practical scenario with a problem. Right. Okay. So as I said, supervised learning techniques are a few I have listed, which is a linear regression, logistic regression, decision tree, random forest, Navi-Bayes algorithm, support vector mission. All these are the comes under supervised learning technique. Coming to supervised learning technique, regression. Now I'm talking about, I'm demonstrating, is used to estimate a real values. What real values? Cost of the hours. What, which means that probably, houses, now year by year the houses of the cost is going to be increases. Next year in Hyderabad, 1200 safety house, what could be the price it would be, will be predicted with the help of a linear regression. And number of calls, an user per day, if we speak 5 hours in the phone call, tomorrow how many hours he is likely to be make a call can be predicted, isn't it? Total sales, e-commerce applications, based on the historical data, we can predict tomorrow how many users are going to be purchase certain product from a particular e-commerce application can also be predicted. So based on continuous variable, you have to understand linear regression algorithm will be applied when your input data is continuous data. What is that continuous data? I'll be talk about all this. And logistic regression, and decision tree, random forest, Navi-Bayes, these algorithms are also used to classify certain data based on the approach called as a supervised learning approach. All this data will be taken input data as a supervised data, and it predicts a certain output, isn't it? So now I'm not going to talk about all this. Let me go ahead with a linear regression, because our topic today is a linear regression. So how exactly it works practically, let me demonstrate. Right. Here I told you linear regression analysis comes under a supervised learning technique. It is used to predict an unknown value of a dependent variable with the help of a known value of independent variable. Here, what is dependent variable? What is an independent variable? In the formula, let me talk about. This is my sample data. This is my sample data. This is my sampling data. Your data set. This is my sample data set. This data set is talking about age of a person, age of a kid, age of a children will be an input variable. This is an input feature. It is an input feature. It is an input feature, or it is an independent variable. This is IDV, independent variable, or it is a feature. It is a feature. It is a feature. Coming to weight, if we know the age of a person, let us suppose if a kid age is 1 month, his weight is 1 kilo. Their weight is going to become what? It is a target variable. It is a target variable. During the training process, we have to take some sample survey data. If the kid age is 2 months, his weight would be 3 kilos. If the age of a kid is 4 months, the weight is going to become 3 kilos. If the person age is 3 months, he would be likely to have a weight is 2 kilos. If the age of a kid is 5 months, then he is likely to have weight will be 5 kilos. This data will be talks about a sample data. This data will be collected during a survey process. Here our aim is this simple linear regression is going to predict let us suppose the kid age is 10 months. What is a weight of a kid is need to be predicted by your algorithm, need to be predicted by this algorithm. You might know, most of the hospitals, diagnostic people, your body mass index, your weight, based on the age, based on your symptoms, they are going to be calculate your weight also. If your kid age is 10 months, he must have 12 kilos will be there. Suppose if a kid is 12 months, means 1 year baby, has 20 weight, 20 kilos. This is, it is overweight. A 12 months baby, at max he should have 10 kilos of weight, or maybe 12 kilos of weight. It should not be at 20. Like that, your linear regression model is having an ability to predict a target label. A target label is called as dependent variable, and the input variable is called as independent variable. How you are going to write your generalized supervised learning technique, y is equal to f of x, which means what? If we train our model with a function of x, where x will be input variables, input features, such a way that we will be able to find a target variable is called as a y, where y is a weight which likely to be predicted for the unknown input value called as a age. That's what I read. So it is a help to predict a known value of an independent variable. If we know these values, we will be able to predict an unknown value of a weight. That is what the linear regression would be applicable. You have to understand one important point. The linear regression will take an input functions or continuous values, continuous values, continuous values, continuous values, right? So, and even target also, it is going to give you a continuous value. Let me go ahead. I hope you understand what is the relationship between y and f of x. Yeah. So here is that. Y is equal to f of x will be, here weight is y, x is age. X is the independent variable, y is a dependent variable. Okay. Here. A y can be dependent on one variable, it should be called as a linear regression. But sometimes you can be able to tell that, a weight of a person can be depending on another variable is called as, height also. I am going to take height of a particular person. Height of a particular person also make a difference. So what is the weight of a particular person? If a height will be 2 feet, this can be a weight. If the height can be 3 feet, if the height can be 4 feet, if the height can be a 5 feet, if the height can be 7 feet, then based on that the weight of a person is likely to be determined. If the weight will be depending on more than one variable, age and height, then such a model is going to be called as a multiple linear regression. It happens. If y will be depending on x1, x2, x3, x4, x5, any number of a dependent variable, such an analysis, such a model is called as a multi-linear regression algorithm or multiple linear regression algorithm, we can say. Isn't it? See, let us suppose a person is positive or not, COVID positive or not, we wanted to check. The symptoms are the input feature. Class plugins can be done with class plugins. Yeah, right. Yeah, I hope you understand the difference between linear regression and as well as multilinear regression. Okay. Right. So here I'm just plotting. I'm plotting whatever the above input data I have taken. This data set, I wanted to plot how the relationship between weight and as well as age. I just plotted over here. So these are the points. I plotted the relation between weight and as well as age of a particular baby. If we draw the linear line, only 3 points are visited. These 2 points are little away from this particular linear line, which means what? There is no proper correlation between these 2 points with this particular straight line, isn't it? See, the straight line in linear regression will be represented with generic manner, which is y is equal to mx plus mx plus, right? So here So y will be a target variable, x will be an input variable, m will be a coefficient of this particular slope of this particular x variable, where c will be a constant which will be intercept, the intercept where y-axis is going to cut, where y-axis is going to cut. This is called as C. This particular place is called as a C. This is an intercept, we can say, isn't it? This is a generic equation to represent a linear line over the searching space. Here I have plotted age is a one particular input variable, weight will be one particular variable I have taken. Weight will be a target variable which is likely to be predict. Age will be an input variable. This, wherever you draw the straight line, this is a straight line, or else you can take this is a straight line, or else you can take this is a straight line. Wherever you draw, as much as possible, the points which are lying over the searching space will be lying over the straight line, so that which shows you that how strong correlated between two important features. So this knowledge we have acquired from the linear algebra or maybe linear equations, isn't it? So this particular plot will give you the relationship between x and y variables, isn't it? Okay. Okay, so here what is our aim? Our aim is that, if we create a simple linear model, because simple linear regression model is a supervised learning machine learning technique which is going to train with your training data set, and if you give an unknown input label, it is able to predict a new value of a weight according to your input data. So for that, what we should do, our training data should be learned from the model, and then it is going to make predictions according to your application, isn't it? Right. Okay, for our training data, to get an idea how exactly well this model is learned is based on the relationship is going to be available or maybe lies in a given data. Okay, to get a machine learning linear regression model for our data set, isn't it? So this particular equation is learns the relation between the input data which you have trained your model. As soon as your data will be trained by this particular equation, such a way that is your linear regression model will be provide you or enable you to predict a certain output values according to your wish. So if you know the age, weight will be predicted, isn't it? Whether it is outlier or whether it is a reasonable weight of a particular person based on his age, based on his height, that analyzer is going to distinguish in terms of a graphical visualization. The correlation between your age and weight graphically estimated with the help of certain metrics called as an RMSE or maybe a correlations, pairs and correlations, right? Okay, so y is equal to b naught b1 into x will be here b naught will be an intercept point, b1 will be a slope of a variable input called as x. Here y will be a target variable. It is a target variable which is a dependent variable dv. X will be independent variable. This independent variable, independent variable can also called as an input feature, isn't it? This can be called as an independent variable. This can be called as a predictor also. So based on the scientific domain, you have to learn certain terminologies. So here, as soon as your training data will be trained with this particular model, isn't it? So this equation is going to be it is going to enable you to predict certain outputs. So here x is a predictor or maybe an input variable, y will be a target variable or maybe a dependent variable, where b naught will be an intercept point where the place where this particular place is called as an intersection where a line will be cut the y-axis. This is a y-axis, this is the x-axis. Right. So B1 will be the slope that is going to be calculated. Isn't it? So as a whole, B0 and B1 are the coefficients that are to be estimated in order to fit our line, which is going to give you the best relation between two input parameters. Okay. Let me take an example so that you will be able to understand. So I told you that the B0 in the equation will be an interceptor, which will be determines a line is intercept or cut the y-axis. It is useful for every computation of our relationship. Okay. In machine learning, the B0 indicates bias. Error rate. Bias will be useful in order to calculate your prediction output called as a y. It is added for every prediction that we make for predicting a y value. Okay. B1 will be, it is a one coefficient which is a slope of an input variable. It defines the slope of the line, how x value can impact a value of a y before adding a bias value, isn't it? So x like B1 and x will be multiplied those values. So the based on the value of a x, the impact of the y is going to be changed, isn't it? So this is slope is also be determined based on certain formula. So okay, here I'm taking some sample example. Here, case 1. Here 0, 1, 2, 3, 4 are the x values. These are the y values. Now if we consider this is a linear line equation, here this 5 will be B1, this 5 will be B1, you assume that, and 2 will be B0, isn't it? So if we multiply 5 B1 value, 5 into xn value, for example, x will be 1. If it is 5 into 1 is 1 plus 2 will be 7, then the obviously y value is going to become a 7, isn't it? So likewise, so the place where this line is going to be cut, so this is indicates, this particular position indicates 2. Therefore they have taken here the 2 as a B0. B0 will be an intercept a position where the a line will be cut the y-axis. That's the reason they have taken 2. And coming to 5, it has to be calculated based on certain values, variance and as well as, right? Okay, this is a one case. In this case, you have to understand the slope is positive, means if the value which is slope for the x is a positive, if x is increases by 1, then y will be increases by 5, where y intercept is a 2. Sometimes this 5 can be negative values also. See, simply if your road will be slope is high, then obviously slope of the road is a positive. If we go down, let us take a second case. You look at here, the minus 0.4 will be, it is a negative value. If you look at the slope, it will be go down. It is go down, which means what? If the road will be a down, then it is going to be taken as a negative slope of a road. The time the B1 value will be considered as a negative value. Coming to 7.2 will be, at this case, will be this position where a straight line is going to cut the y-axis. Okay, based on the value of B0 and B1, then the y is going to be determined, the output predicted value. Here I wrote slope is a negative called as a minus 0.4. When x is increases by 1, y will be decreases, because it is a universal relation, a proportional relationship between x and y based on the B0 slope value. Obviously here 7.2 will be a, it is a intercept value, right? Okay, now there is another case. There is no slope at all, then the road will be very, constant, means, there is no slope. Either slope is positive, it will be go up. If it is negative, it will be go down, but it is a constant. If it is if the constant, there is no slope, obviously you will have only intercept point called as a -4, isn't it? This is a place where only, which will be indicates you that only a p naught value. Then based on that, the y value is going to be determined. So these are the different cases where likely to be happen in real-time scenario, based on the b naught and b1, which is m and x, m and c values are major roles. If how effectively we will going to be calculate slope and intercept points, based on that error is going to be decreases and prediction is going to be calculated and produces very effectively, right? Okay, right. Here I told you the goal of the linear regression machine learning supervised technique is that to find the best estimates for the coefficients to minimize the errors in predicting of y based on the x variables. How b naught and b naught is what here? b1 is going to become a slope of a line. How it is going to be calculated? Here we require input values. X1, xi is nothing but input. Here it is a age. Here it is a age. X will be a age. For the age, whatever the values we have, we want it to be calculated mean of x into, here y values are called as what? We had weight. We had weight according to our taken sample data. It is a weight. For that, mean has to be calculated, divided by xi minus mean of whole square. This complete computation of this equation will give you a b1 value, which is a slope of a line, which is a slope of the line, isn't it? Okay, so before calculating b naught, we have to calculate b1 because the b naught, which is an intercept, will be depending on the x value, isn't it? So which is a b1 value. So mean of y minus b1 into mean of x will be give you this intercept value called as a b naught value. So as soon as you know the b1 and b2, b naught, obviously what is the equation we have? Y is equal to b naught, isn't it? Plus b1 into, isn't it? So x, where x is what? Input variable, isn't it? So we have to calculate b naught and b1 for every iteration point of view. Then only we'll be able to predict a y value. Right. So let me go ahead with a sample example with a problem so that you will be able to understand. Yeah. So here I'm taking one one example where so I'm taking firstly when we are trying to apply our machine learning supervised model called as a linear regression to predict a certain outputs. It is an analysis between the relation between two variables. Simple linear regression technique would be applied. If your independent variable have more than one variable, then the y will be predicted. This particular technique is called as a multilinear regression algorithm. So I'm taking an equation to be represent a straight line called as a y is equal to b naught plus b1 and x. This is a straight line. It is a straight line represented according to according to linear algebra, isn't it? Okay. And here, as I told, that the estimation of b naught as well as b1 need to be computed before going to calculate a prediction of the value called as a y. So I told already b1 need to be calculated, isn't it? And let me go down. Yeah. So b1, in the b1, I already told that here we have to calculate a mean of corresponding x and corresponding y for the variable in the data set whatever you have taken, and xi will be called as all the values will be applicable to find out the mean of x and y, and based on that it will be calculated for the ith values also. here I am taking an example, whatever I have shown you in the PPT. So here I am taking the data set. Here, so here I'm taking an example that this is a data set. So here X will be assumed as age of a kid, age of a child, and Y will be, a target variable is called as a weight. You just assume that weight. Right. So now I'm just training my model, which is a simple linear regression model with a simple data set, because the data set might not have only 5 samples. It might have many records that based on the or your technique which you are going to apply, isn't it? So here what I'm trying to say is that with this data set I'm trying to be training my model. I'm trying to be training my model. Right, I'm going down. So what is the mean of X? Obviously the 3 will be the mean of X, because while we computing B1, which is a slope of a particular line, we require mean of Y and mean of X. So 2.8 will be a mean of Y. So in the numerator, in the B1, so this is the equation is supposed to be calculated, right? So obviously, so xi value, each value you have to take and we have to substitute, and mean of X will be 3 and mean of Y will be 2.8, and then we have to calculate the mean of X and as well as mean of Y. Let me go down. Okay. Here this table gives you that, how exactly a numerator is calculated. So these are the values of 1. So 1 minus minus 2 will be, so minus 2 will be after making 1 minus mean of 2 will be 3, so which will become a minus 2, isn't it? So and Y will be 1, so here 2.8 will be a mean of Y, and 2 will be 2, or I don't know, I have forgot in the above. I think 3 will be a mean of X. 2.8 will be a mean of Y. So if we perform the according to operation, you will be getting a resultant values. Finally, we are going to be multiplied. So these are the resultant value. For that, if we perform the summation, then the numerator of a B1 will be 8. Now denominator we have to calculate. What is the denominator? Here there are also certain point to be calculated. Yeah, so denominator in the B1 is a slope. This is the formula where, obviously xi already, mean of X resultant value, so that, isn't it? So xi minus mean of X will be, these are the resultant values. So after computing, and then we have to perform the square operation, so that these are the values of the complete equation. After that, we have to perform the summation operation. So what is the resultant value you are going to get? You see now for the denominator, 10 will be the denominator. 10 will be the denominator. So 8 divided by 10. So now we have what? 0.8 will be a, isn't it, a B1 value. So now we have B1 value as a 0.8. Now it's time to calculate a B0 value, which is an intercept of a a given equation, right? Right. So here step 3 is that. So here I already told you is that. So if you have a B1, so obviously B0 can be calculated by applying mean of Y minus B1 into mean of X. Now in our hand, we know B1, which is a 0.8. right? 0.8. We know the mean of x, which is 3. We know the mean of y, which is 2.8, isn't it? If we compute the whole expression in this substitution, you will be getting a b naught. Now what would be obtained b naught? Obviously we obtained the b naught value called as a 0.4. Now in our equation, it's time to predicting y. Because the b naught, you know that, which is a 0.4. B naught is a 0.4. B1 will be 2, like B1 will be what? What is the B1 value? Obviously, what is the B1 value? 0.8. 0.8. So now if you have x value, where x is what? Already in the data set called as a age. Age related column values are going to become x values. If we supply x as a 1, by performing this whole operation, you will be able to get a y value. Now these y values are predicted values, not earlier values while you training your model, isn't it? So if you look at a correlation in graphical representation, when we draw the linear equation, linear line, completely different from the before prediction of y, after prediction of the y, isn't it? So let me go ahead. See, our motto is we wanted to predict y value. Y is weight. If you know the age, weight can be calculated, right? So let me go ahead. This is a step 4 is prediction. Now, isn't it? So in the prediction, I have substituted all the values. 0.4 will be b naught, b1 will be 0.8, x will be a value will be taken from the training data set. So now, transformation of a given data set into a predicted y values for each input values will be as per the linear equation. Now this table, if you look at actually this is a training data called as a age. If you know the age of the baby is 1, his weight should be 1.2. But if you look at a y value before prediction, training data, this data will be 1 only. This value have been changed because this is a predicted value, because simple linear regression model have been trained with your input sample data. Now it is predicting a age. Here y is age, sorry, y is weight. Y is weight of a kid, right? If the age of a kid is 2 months, then he should have 2 kilos will be the weight. If the age 4 months, then 3.6 will be, a weight a baby should have. Suddenly, if it goes to 8, that is not a normal weight. Probably baby will have overweight, we can say, isn't it? So like that, our simple linear regression model will be helpful as to predict approximately, not 100%, right? Approximately a valid age weight will be predicted based on the given weight. 3 will be the baby weight, 2.8 will be the expected predicted weight of a baby. If the baby age will be 5 months, he should have 4.4. Now, if a new testing during these are the training data. Now, during testing data, I'll be giving 24 months will be a baby weight. You have to find out what is the weight of a particular person will be given by your simple linear regression model. But here the point is to be understand is that how far these values are accurate. That accuracy error will be calculated with root mean square error. You people might have learnt RMSE is a formula to calculate an erroneous percentage or error percentage in prediction, continuous value by the any technique that will be give you that how far this prediction is error. Let me go ahead. Okay, let me go ahead. So here I'm just visualizing you a scatter plot between before prediction of y values, after prediction of y values. If you look at, I'm taking some color. The light, this color will be predicted y, means weight. After predicting a weight of a baby, what is the correlation between age and weight will be this line. This point, this point, this point, this point, and this point. If you look at the line, very straight line, all the points are lying on the straight line, which means that x variable called as the age, y variable is called as a weight, have very strong correlation between them. But if we draw the straight line, this point before prediction, actual y, weight of a person will be this point, this point, this point, this point, this point. See, if you straight line, if you draw here, if you draw the line here, hardly not one point also visited. If you draw the straight line from here, 1 point visited. If you draw the straight line from here, hardly no points visited. If you draw the straight line from here, no points visited. So there is no proper correlation between age and as well as weight before prediction of weight. Now if you look at, the line will be very straight. This is what I'm expecting. If we apply the linear regression algorithm by training certain data such a way that how correlation between x and y, what is the straight line is visiting the points. See, these points which are visiting, lying on the points are very support vector lines, support vectors we can say. They are very strongly recommended and classified, we can say, isn't it? So this is how, so we can say, so obviously by seeing this diagram, so this strong correlation between after prediction of y will be very, very high than the before prediction of y. That practically using Python program also I'll show you. Before prediction, how much correlation between weight and age. After prediction, what is the correlation that has been changed. Let me show you till then. Just till then you try to understand. If you have any queries, please, you can stop me, you can interrupt me and ask whatever the doubt while I am explaining you. You need not to be hesitant over here. Here, I told you, you are predicting y value. How far those predicted values are valid, accurate, that will be, estimated with, there is a formula called as, RMSE. This is a mathematical formula, which is a metric, root mean squared error, which is estimate an error score for our predicted values and before prediction of the values, isn't it? To determine the accuracy of our model while you are applying continuous data, we are going to use RMSE metric. Okay, how you are going to calculate error? Here, if you look at the formula, y cap indicates, predicted values. Y suffix I will be indicates before predicting y values. If we subtract and performing the square and divided by total number of values called as a 5, then the value which is going to be written, this equation will give you RMSE. That is the percentage our prediction is wrong. Right? Okay. Right. Okay. Let me go ahead. Okay. Yeah, here I wrote, and I have calculated all the values also. I have calculated all the values. So there was actual values. While training your model, these values are actual values. Y values means you just assume these are the weights of a kid. Predicted. Y predicted. After applying your simple linear regression model, the y values have been predicted as 1.2, 2, 3.6, 2.8, 4.4. Completely they are different from the actual values of y. Here, to calculate the RMSE, predicted values called as a y cap minus y. So that these are the values you are going to be obtained. isn't it? So here we have to be squared that those values so that there's a resultant values, isn't it? So if you perform the summation, 2.4 will be the corresponding value. You go ahead. If we substitute in the equation, isn't it? So now what exactly you understand here? RMS equation is that 2.4 will be the value which you have obtained from this, divided by 5 will be total number of samples you have produced as a training data, isn't it? If we perform the square root for the given output value, then the 0.69 will be a value which is each prediction of a y value is wrong by 69 will be percentage value. By 69 percentage value will be wrong, isn't it? See, according to scientific observations, this can be go up to 180. This can be go up to 180. This is erroneous. Before 180, if we get error rate, that will be valid and acceptable for predicting certain outputs. This is a basic observation I wanted to be make noticeable to you, isn't it? 69 erroneous prediction is a highly valid algorithm. So if you are still, if you are not happy, then you go for other techniques, whichever recently or maybe researchers have been designed or innovatively or maybe invented, with which if you are able to reduce this particular, that this is erroneous value, so that algorithm is going to become a best algorithm, we can say. This will be accept up to 180. If this value will be go beyond 180, it is going to be rejected model. This model is not a valid model. This to predict a continuous data outputs, you have to choose another, there are other algorithms also, isn't it? So bootstrapping algorithms, there are other algorithms where linear continuous data can be applied, right? So this is the theoretical points to be understand. So about to calculate an accuracy of a model, right? So let me go for the same scenario. Same scenario I'll be explaining you with a program, Python program, right? Okay. Right. See, I told that while theoretically, conceptually, I have explained correlation between weight and age before prediction and after prediction. I'll just make you understand here. Yeah, if you look at here in this program, this is a Python program. I'm using, yesterday we had a discussion about NumPy, right? Here we require somewhere NumPy it is a module in which there is a function is called as a covariance. COV is a built-in function which is covariance between two variables can be identified with the help of this particular function. This function is derived from which module? There is a module is called as a NumPy module. There is a module which is NumPy will be a module which is derived from which package? There is a scikit-learn package. Right here, if you look at, there is a SciPy. SciPy is the package in which there is a module is called as a statistical import. There is a method is called as Spearman R. Spearsense is the one particular author. It is author name with which the correlation between two variables can be identified. See, I'm mapping between theoretically as well as conceptually and programmatically, isn't it? So now I'm taking here, there is a data set. What data set I'm taking? 1, 2, 4, 3, 5 are values of X, which means it is a age of a particular kid, Coming to this 1, 3, 3, 2, 5, these values are, this is the, it is called as an array. We can say NumPy array, isn't it? This is going to be called as a Y values. I'm trying to be store our whole data set, table of data set into in terms of array. Now, by writing this particular line using for loop, I'm going to read from the data set all the X values into X and all the Y values into Y. So where X is the one object, Y is an object. Now X is holding X values, Y is holding Y values. X is a age, Y is a weight. Now here I told Spearman R is a built-in function for which if we give X value as a parameter and Y value as a parameter, which will be give you the correlation percentage between X and Y accordingly, isn't it? Right. So now I'll be just executing here. I'll be executing. You look at an output. I'm executing this particular code. Say I'm here. I'm using Jupyter Notebook. Yesterday I have used Colab. If you look at a screen, both are looking like same. Cvola is also provided with this Jupyter. Here also it is a Jupyter. Jupyter can be explicitly on alone software can be installed, or else if you install the Anaconda, in which Jupyter is a built-in one integrated tool. I'm executing this particular program on the Jupyter. So if you look at an extension of your program, .ipynb, right. I'm executing this code. So still it is going on. So please wait. It is still reading the values, and it is going to take little time because Python uses interpreter. It is not going to use a compiler. Interpreter is a little slower to give the output. Execution time will be taking more than the compiler, but the difference is that compiler will be not generates object code, which is a portable code, but interpreter will provide object code, which is a portable code. Write on one platform, run on anywhere else. That is an advantage of an interpreter, even though it is a slower, but it is more powerful. For that reason, in the Java, basically the Java code will be run on compiler, and then it will go for the just-in-time compiler called as an interpreter. Then the object code will be generated. So it is still running. Yeah, if you look at, output has been produced. I hope you are seeing my screen. Spearson correlation, which 0.82 means what? 82% of the correlation between you have drawn the graph, right? So which means what? The points are lying here, like this. If we draw from anywhere else, the correlation between X and Y. Correlation between X and Y will be 82% will be the a correlation between X and Y. Now let me execute after prediction of Y. What is the correlation you just see here? Here, if you look at the below program, it's a Python program. If you look at here also, I'm going to calculate the Spearson R. Here, if you look at the values, X values are same. X1, 2, 4, 3, 5. X values are same, but we are predicting Y values after learning simple linear regression for a given sample data set. Your outputs of Y values are 1.99, 3.59, 2.8, 4.39. These are the predicted Y values. After predicted Y values, what is the correlation between X and Y? You see now probably your correlation have been strongly built. It will be increases. Now I'm executing this code. Let just check the output. Yeah. So what is the output? Probably you might have seen my screen. 97%. Earlier it was 0.82, 82% of the strong correlation between X and Y. before prediction of y. Now after prediction of the y, the correlation between x and y will be 97%. Which one will be acceptable? Obviously, the correlation between x and y after prediction of y will be acceptable to generalized to produce certain predictions that if your age is if your age is 30 years, isn't it? You should have a weight is up to 55 kilos based on your height also. Like that, the prediction will be happen based on this particular concepts. Internally it happens, but we are not going to see all these formulas, all this. Wherever you see our blood samples and sales, even though you can see, your past percentages, even though the sales of houses, even though petrol consumption of the car, next year how much it is going to be given, next year how much it is going to be given. So per consumption, that is also continuous values, isn't it? Like there are n number of places where continuous analysis variable would be happen. So you are going to be analyzing the diagnosis between two variables or between three variables. That's up to you, but you can apply wherever an input variable is a continuous values and output variable is also continuous value. Like that you have to analyze it. I hope you understood. Let me go for the place where Python program would be implemented for our purpose. Yeah, okay. Now I'm going up. Yeah. So here I am demonstrating you without using any built-in Python functions. So this is the program I wrote without using any built-in functions provided by scikit-learn. Scikit-learn is, it is a package from which machine learning techniques functions are available. I am not using any functions, just the way mathematically I have explained to you. In the same way, I am going to be explaining you with a Python code. If you know the basic Python, you will be able to understand over here. So here, what are the steps are involved here? So because calculating mean and variance of a given variables, covariance will be calculated. Estimating the coefficients called as a B0, B1, B0 and B1, isn't it? If you know the B0 and B1, by substituting B0 and B1 in the prediction, y is equal to B0 plus B1 into x, and we are able to make predictions, then finally we are going to calculate the RMSE value. So how it happens using Python program, just let me execute and let me show you. Okay, yeah, let me go ahead. Firstly, I'm going to calculate, first calculate mean and variance of a given variable. So this is the data set I'm taking. This is the data set I'm taking. Here, x is age. Here the x is age. Y will be weight of a particular person. Isn't it? The same data set I'm taking. How you are going to write a program? Right. So here, what I'm doing here is that, firstly, step one is what? Calculating mean and covariance of a given variables. Right? Because we require that formula to be a substitute. So what I'm doing here is that, so I'm just calculating. I'm calculating. Yeah, I'm taking a data set which is before prediction x and values I'm taking. Now we have x values into x, y values into y. X and y are the objects. Right? Now I am calling mean of x, means this mean of x is user defined function. You have to understand, it is a user defined function, isn't it? So mean of x and mean of y, two functions I am calling at a time in a single line. When you call mean of x, it is we are calling a function, it is directly go to the place where the definition of the function is available. Here what I'm doing here, I'm taking values. What are the values here? Values, x is the formal actual parameter, values are the formal parameters. I hope you know the functions concept. X is the actual parameter, y is the formal parameter. X is having the values are 1, 2, 4, 3, 5, and y is having values called as a 1, 3, 3, 2 and 5. So as soon as you take these all x values into this particular parameter, what we are doing is that here we are performing, we are taking a values one by one, sum of a values divided by the, what is the length of the value is 5. Length function is a built-in function for which if we give supply, it gives is a 5 as a corresponding output. So sum is a function which will take all the values and then it will be give you the corresponding mean of x. The definition will be written, this will be written the mean of x value called as 3. Similarly, mean of y, whenever you call mean of y, the same function, it will be go to the same in this definition, but this time the values will be take y values, and then the y value mean will be 2.8. So this line will give you 3, and 2.8 will be a mean of x and mean of y. And similarly, we want a variance. Now if you look at where to calculate a variance of a given variable, we require two values, x data set and mean of x. And similarly for the variance of y also, y data set and mean of y. If we calculate this particular two functions, the function will be go to this particular definition, and then it will be consist x values initially, mean of x will be 3. Now it takes all the values of x and mean of x, then it is going to perform variance. This is available for you in the numerator. You know that, right? Isn't it? In the denominator, variance will be denominator, covariance will be a numerator. So these values are going to be calculated. Finally, will be give you the corresponding value. Let me execute now. Let me execute this code. Now I'm executing this code. Yeah, if you look at output, I hope you are looking my screen. If you look at output here, x related statistics are mean of x will be 3 and mean of y will be 2.8. This theoretically also we have calculated, conceptually we have calculated. The values are same because the same data set we are taking as a sample data set, historical data set. So variance of x will be 10, variance of y will be 8.8. So probably we require variance of x only, isn't it? Right. So we in our hand now mean of x value we have, mean of y value we have, variance of x, variance of y we have. Now we will go further, to calculate a numerator. Now what is the b1 value, b1 formula, which is a slope? Slope will be, you might have seen the formula is xi minus mean of x into yi minus mean of y, isn't it? And divided by, this is the numerator is the covariance, denominator is the variance. Already we know the variance of x, which is a 10. Now we are calculating the output value of this particular equation. So this equation in statistics can also be called as a covariance of two variables called as a x and y. Now I'm calling what, so I'm calling a covariance it is a user defined function for which x data set I'm giving, y data set I'm giving, mean of x I'm giving, which is a 3, isn't it? And mean of y I'm giving, which is 2.8. If we pass these 4 parameters, so that the request will be go where the definition of the function is available. Okay, here, so all these are the formal parameters, these are the actual parameters. So here the covariance to be calculated, we are going to be stored with a 0.0 initially. So if the length of the x is a 5, if you know there's 5, obviously x of y will be first value will be taken, mean of x will be 3. Then similarly, first value in the data set y of y will be 1, then mean of y will be 2.8. So this will be repeatedly because of for loop, it is going to be executed 5 times, then it is going to return the covariance of the corresponding value. Now let me see what is the covariance of this numerator. Let us see. Let me execute this code. Right. So here you might have seen So now what is the output you have obtained? So the covariance will be 8. Now covariance will be 8. Means B1 is equal to, isn't it? B1 equal to, now it is covariance will be 8. Already denominator, you know that, which is 10, isn't it? 10 divided, like 8 divided by 10 is going to become what? Obviously B1 is going to become a 0.8, isn't it? So now we know in our hand B1, which is the slope of a line, is calculated, isn't it? 0.8, isn't it? So now I'll be apply the same in subsequent code, so that we are going to be identify B1 and B0 values. Right here, if you look at this code, here what I'm doing here is that I am calculating B0 and B1. I'm calculating B0 and B1. If you want to calculate B0 and B1, obviously what we are calling, there is a function. It is not a built-in function, it is a user-defined function. I told you I'm not using any built-in functions. Coefficients by passing a data set, so that here we are taking entire the data set, x values we are taking, y values we are taking. Mean of x we know that, mean of y we know that. To know the covariance, obviously, you know, covariance means B1 is equal to, here covariance will be this entire, the equation output will be, you know, top will be, it is, you know, 8. It is 8. The variance we have already calculated, which is 10, isn't it? So then 10 divided by 8 divided by 10 is going to become a B1. And to find out the B0 value, obviously you know that y mean minus B1 into x mean. So here B1 value should be required before going to calculate a B0. So obviously 0.8 will be substituted. Y mean is going to be a 2.8. X mean 3. Obviously B0 value is also going to become. Now let me execute. What is the output of B0 and B1? Exactly, it gives whatever the conceptually and mathematically calculated in the previous calculations. Now I'm executing this code, isn't it? So you just look at me. The coefficients are B0 will be, you know, 0.4, B1 will be 0.8. So now in our hand we have B0 and B value. So where you supposed to be calculate all these? I'm going to calculate y prediction, y hat. Y prediction is B0 value we know, B1 value we know. Now you take all the rows of x value, all the values of x value, substitute in this formula, so that y hat will be a prediction of y value will be written as a prediction values. So this is how I'm just going to be make all these operations accordingly. Now let me execute. So with which you know, our simple linear regression model is going to take a training data and testing data. Yeah, so I'm executing this code. Yeah, executed. Then next you go ahead. So here I'm calculating RMSE value. You know that RMSE, you know, prediction minus actual y value. This line will give you that how to calculate a predicted value of y minus actual value of y will give you that prediction error, which is a RMSE value, which is gives you RMSE value. Actual and predicted values of y value will be given, isn't it? So with which you will be able to calculate, you know, RMSE value also, you know. Right, I'm just executing this code. Okay, code is executed. Now finally, this particular code will give you that, you know, for every level, it is going to give you what is the error rate. Yeah, okay. So now, if you look at what is the RMSE value, you have seen theoretically. I told you, I have explained you, I have calculated also. 69% will be an RMSE value because the same data set we have given. Yes or no? So for that, RMSE 69 will be, you know, acceptable, highly acceptable. It is a valid. Up to 180 RMSE value can go. Till then, this model is acceptable to predicting output of continuous values. If it is go beyond 180, then the model is going to be rejected. You have to change the features with which your output value is going to be changed accordingly, isn't it? I hope you people have understood how exactly simple linear regression model is predict a specific target value, right? So this whole code you have understood without using scikit-learn methods. Now I'll be going for the another method, another technique for predicting another aspect with another code. Yeah. If you have any queries, you can ask me now at this moment. If you have any queries, please you can raise your question so that I'll be clear, and then I'll be going for a code where with the scikit-learn methods, very simply the size of the code can be reduced. I'll tell you how exactly it happens. My dear participants, please, if you have any queries so far in application point of view, or maybe you might have a number of imaginations, what are the other applications can be applied in mechanical, in civil, in case of electronics, electrical. You ask me the questions so that I would be able to answer your questions, that where this simple linear regression is going to be applicable for predicting a target value. Please, you can unmute yourself and you can ask me the query so that I'll be go for the another technique, which is using the same technique called as a simple linear regression using scikit-learn methods. Yeah, please.
Dear participants, please interact. Please pose your questions.
No questions? Shall I go for the next example?
Yeah, please proceed, sir.
Yeah, because probably they might be hesitating to ask the questions. So it's an open platform. This workshop is meant for you, not for us. Yeah, somebody have commented. Yeah, one. See, Sneha, actually, covariance is the subset formula when we calculate the linear line. Basically, linear line will be represented is equal to y is equal to mx plus c. To calculate, to calculate, a slope of a particular line, covariance is going to become, here I just calculated mathematically. You might not have observed over here. Yeah. So covariance here, if you look at my screen, please you try to understand very carefully. Covariance between x and y variables I'm just calculating. So in the formula, in the b1 is basically, it is a slope of a line. b1 is having two numerators and denominators. This portion is called covariance. This portion is called as a variance, isn't it? The variance can be calculated for one particular variable. Covariance will be calculated between the two particular variables, isn't it? This particular covariance gives you that the strongness or maybe a relationship between two x and y actually, isn't it? So this covariance is nothing but correlation between x and y, I can say. In statistics, we might have calculated all this with which we are going to be predict certain things, isn't it? So covariance and variance are going to become formulas to calculate the slope of a particular line. There I have taken some data set. So here the x is a age of a particular person, isn't it? Y is going to become a weight of a particular relation. So between relation age and weight of a particular person, what is the strongness, the strength of these age and weight will be gives you this the covariance. In this case, you can take another example, isn't it? So now you will take now you will be taking prices. X are the prices, historical data, prices. Prices is nothing but house prices. Now probably 10 years prices you take. In 2000, 1200 SFT flat, it might be cost around 6 lakhs. After next year, it might be 7 lakhs. Next year, 8 lakhs. Next year, 9 lakhs. Now in 2020, 1200 SFT will be almost at 50 lakhs. Now I am asking you that here the target label is called as predicting next year price. Predicting price will be a target variable called as a Y. What is the next year? The same 1200 SFT will be likely to be their house price. It's your responsibility to calculate. Covariance in this context give you how correlate between the price of a historical data as well as the Y will be given by this covariance. So you can imagine there are n number of cases where you will be able to take, isn't it? And accordingly, we are going to be calculated over here. Yeah, okay, right? I hope you understand. So some little mathematical knowledge is required over here. So the same statistics might not be applied, but we are using the formula, but the input features will be changed. Domain to domain and, area to area, maybe, branch to branch, right? Okay, any other queries? Yeah, okay. Yeah, let me go ahead. Probably now it's time 3:15. Probably I have only 15 minutes. Let me execute on another program using, same simple linear regression. So here, yeah. So here I'm taking same algorithm, simple linear regression algorithm, but I'm taking another example data set. What is my data set I'm taking? Prediction of your brain size, any human being brain size based on your head size. There is a need of this kind of analysis, diagnostic analysis based on your brain size, based on your head size. What is the size of your brain can be predicted. See, nowadays miracles would happen. Probably the first born baby might have a brain size might be, head size might be more, little larger, or maybe little more. And what could be the brain size? Many cases scientifically we have to test where based on your head size, brain size could be calculated. How we are going to be predicted? That will be happen using simple linear regression algorithm with the help of built-in functions, scikit-learn functions I am using. I'm not going the same explanation without built-in using. I'm just probably the steps carried out in the linear regression will be the same, but I'm taking another data set and I'm using, built-in packages and built-in modules where I'm using NumPy, I'm using pandas, there is a matplotlib. Matplotlib is a module which is going to be derived from the scikit-learn to visualize the graphs, scatter plot, probably God chart, maybe pie chart. There are different kinds of line chart. Many charts can be drawn by providing this particular package, isn't it? So here what I'm doing here is that for that step one is we have to import a related modules and reading the corresponding sample data set, and afterwards we have to split the data into training and testing. This is a point to be understood. See, most of the supervised learning techniques are going to follow training and testing are very important steps. During if you look at your data set having 100 samples, isn't it? So in these 100 samples, 80 samples are going to be trained. 20% of the samples are going to be not available in this particular trained model. But how far your model is going to be classify them, how far this model is going to be predicted, are they going to predict it truly or maybe wrongly? That is going to be tested with the help of a 20% of the testing space. Probably earlier guest faculties might have explained you theoretically how exactly testing and training would happen, what is the need, because these 20 samples are unknown to this particular model. In that case, all 20 will be recognized accurately, or it is not predicting properly. Based on that, we are going to tell that this model is how far it is correct, how far it is incorrect. Right? I hope you understand. So let me show you the same steps, whatever I told using scikit-learn. I'm explaining you now. Here I'm taking. So here, firstly, let me import all these models. Yeah, it is getting loaded. It is getting loaded. So whenever I am executing, the pandas, numpy, matplotlib, time, all these might be available in the hard disk. Wherever in my computer localhost, from hard disk to RAM, it is going to correlate with the help of linkers and loaders components. So that is going to happen when we import a corresponding libraries in C or C++, Java, or maybe in Python. Yeah, the libraries have been imported. So here, if you look at this code here, I told head_brain is my data set name, which is available in CSV file, isn't it? That is available E drive NTH machine learning sessions, session 2 case study, in which this particular CSV file is available. That particular entire the CSV data set I'm just reading into this object called as a data, isn't it? This data is a data frame. Yesterday we have seen, right? Pandas will have a method called as a read_CSV, which enable you to store completely this entire the data set into data. This data is a data frame where the rows and columns are available. This line will be indicates you out of probably this data set might have a 300-400 sample data. I want to display you only head. Head means top 5 records. It will be displayed to you. Here this line will give you that I wanted to split the data set. Because the data set will have a X and Y, data set will have a many X and Y inputs. But here, the last column will be a target column called as a Y. Rest of the columns are going to be called it as a X. So here, this X data will have, all the columns except the last column called as a Y, where Y will be a target label, X will be input feature. Therefore, Y is equal to f of X in this code. Yeah. If you look at output, the code has been the data set has been loaded. The data set has it is a data frame. These are the indexes of all the rows. Gender details, age range is a column, head size will be a column, brain weight will be a column. In the table we have how many columns? 1 column, 2, 3, 4. There are the 4 columns are there in my table. In this table, in order to perform the training and testing, I just split gender, age, head size are X1, X2, X3. There are the 3 features, but here brain weight will be a Y. It is a target variable. So based on the X, Y will be predicted. It is a Y is equal to B0 plus B1 into X, isn't it? But gender, age range we are not considering. Only head size we are going to be considering. This is going to be X. This is going to be a Y. We can eliminate that. During the pre-processing of the data set, we can eliminate certain columns, isn't it? So if you look at the data set, yeah, here if you go down, X is having brain weights. If you go down, I split it already. There are many values in the data set. I have displayed you only top 5 because of head function, top 5 functions. There are many. if you look at here, the y values have been started. X is the head size, y will be brain size. So I have split it. X will be an input variable, y will be a target variable. X in this context is a head size, y will be a brain size. So based on the head size, brain size will be calculated, will be predicted. Let me go ahead. Yeah, this code is allow you to split your data set into training and testing. So there is a scikit-learn is a superset package from which cross validation is a function. It is a module in which there is a function is called as a train test split is a built-in module. It is a function. This function will be derived from this particular module. This module will be derived from this package is called as a scikit-learn, isn't it? So here what this train underscore test underscore split function will enable you. So whatever the x and y data you have taken, we are going to take a, test underscore size will be 1/4, means what? 25% is going to become a test value, isn't it? 75% is going to become a train value. So here if you look at this particular train and test, so x, if you have a table, let us suppose it is a x value, it is a y value, isn't it? In the x value up to here, it all the rows. Here this particular column, the rows are going to become a train. How much data you are training? 80%, sorry, 75%, because 1/4 we told, right? 75% of the data set will be trained by the model. This 25% of the model is going to become this data is going to become a testing data. This is 25% of the data. So in this particular manner, so this function train underscore test underscore split function, built-in function, make you to train your model in this particular scenario. As soon as you execute, yeah, I'm just executing this particular code. It is getting, it displays the corresponding data set also. Yeah, if you look at, please very carefully, because I'm not in hurry, probably I'm cautious, I'm consciousness, please you try to be observed, because many of the people might not have a clear idea what is happening during training and testing with the help of this particular function. Here x is a training, x and y split it into 4 parts: training, testing. But 25% will be testing, 75% will be training. Yeah, I'm going down. If you look at x train data, so yeah, after then what is started? You can check values also. These values I have taken from the CSV file. I have shown you there is a E drive, there is a in which there is a headbrain.csv file. From there the data is getting retrieval over here. So x underscore test, go down, y underscore train has 75% of the data, go down, yeah, y underscore test will be 25% of the data. Okay. So now training and testing is happened. Training and testing will be data will be split into training and testing. What is the next step? Here I'm going. Now I'm calling linear regression model. So there is a package called as scikit-learn, in which there is a model is called as a linear underscore model, in which there is a function is called as a linear regression. All I am using built-in function from package. Okay, I call linear regression function and represented with one object. because object will have its properties. The regressor is the property which fit for giving parameter as a x underscore train, y underscore train. Because now our model linear regression is training with 75% of the train data x, 75% of the y train data. From x and y, both will be trained our linear regression model. Afterwards, we are going to pass with only 25% of the x data, how y test data is going to be reacted, we want it to be checked. So this all theoretically we have to understand, then only practically what is happening inside it is going to be meaningfully we'll be able to understand. Right. Here I'm just executing this. I'm just yeah. So here still it is going on. Processing is going on. As long as this Python will be looking, black screen, which means the processing is going on. Coding is getting executing. Yeah. So now regression, linear regression model is trained. Now what is our job? What is our job? We have to here we are in this particular line. We have to call, there is a regression. There is a method is called as a predictive method. This is also a built-in method for which what I'm passing as a parameter, 25% remaining portion, whatever we have, will be giving us an input data as a test data to the linear regression model, and we are predicting what it is going to produce the y predicted values, isn't it? Now we have an actual value is called as 75%. By giving a x underscore test 25% value, I am predicting y values, here. So it gives you the corresponding y values. After then, I am just making you the plot, the relation between before predicting brain size, what would be the correlation? After predicting the brain size, what would be the correlation? Both I would like to show you the graph. Okay. Yeah, I'm just executing this code. Code is executed. Now I'm just trying to plot x train and y train and x test and y prediction. This is the code before prediction. What is the correlation? Yeah, so here I'm just I executed. The plot has been shown here. So if you look at this particular graph, probably certain values are visible over the plot, but probably there might be some correlation between the head size and as well as brain size. So we cannot able to tell how much correlation between head size and brain size. So for that, what you have to do, you have to call Spearman or function, and you have to represent them so that the percentage, how much correlation between brain size and head size. So if you look at, I'm executing after prediction of brain size, I'm just making you to plot that. So this is the diagram for the after prediction of the y prediction. If we draw the straight line, probably majority of the points are very closer to the straight line. Probably correlation might be a 95%. Something by seeing this diagram we cannot able to tell unless and until you have to call this particular Pearson's correlation formula built-in function, so that it gives us the corresponding thing. So now what is our aim here? So RMSE value we wanted to be calculated. I'm calculating RMSE value. The model which is predicted, how much it is erroneous. Yeah. So I told you that this particular model for this particular data, 72%. Yeah. So here 72% will be, it is, erroneous. Probably I told up to 180 it will be possible. So obviously it is RMSE model approximately 73 is not bad. It is a good model to predict a brain size based on the head size. So RMSE values less than 180 will be acceptable. In case if you have a higher than RMSE value 180, This would be, it means that it need to be change certain input features. So which means what, only head weight might not be appropriate to calculate or compute the prediction of brain size. Probably some other factors, features we have to consider, and then we have to predict the brain size. This is how, depends on your analyzation domain, what inputs you are taking, what output you wanted to predict. All this would be happen. Probably you might have learned now a Python code, how to execute without scikit-learn, how to write a code for the simple linear regression with scikit-learn packages. I hope you understand. So now probably time is now 3:32. Please, in this case, if you have any queries, please you can ask me about training testing or maybe anything, how it happens, if you have any queries.
Dear participants, if you have any queries or questions, please post in the chat box or straight away you can interact with the sir. Dear participants, Venkat sir.
Yes, sir. Shall I conclude, sir?
Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes,
Yeah,
yes,
probably time is now. It's
yes,
time
sir.
to conclude.
That's true. Yeah, yeah.
Sneha, yesterday's code and materials, PPTs, all these I'll share today in the our group, our workshop group we have, right? I will share all the resources, like whatever resources you are expecting, right? Definitely, I'll. It's important for you to be execute all this. Thank you, Sneha. Yeah, yeah. Janardhan sir, shall I conclude?
Yes, sir. Yes, sir. Yes.
Yeah, yeah. Thank you so much, my dear participants. Probably tomorrow at morning 9:30 we will be meet. Probably due to time complexity or time restrictions, I might not started unsupervised learning. Probably tomorrow I'll be explaining you unsupervised learning with the same similar way, with a mathematically, programmatically, conceptually. I'll explain without any flaws and pros. Please, thank you so much, guys. Thank you. Thank you. Yes.
Yeah, thank you, sir. Thank you very much
Yes,
for our very important and very practical lecture. Straight away, you have shown the machine learning hands-on and supervised linear regression algorithm
yes, sir.
on live. No
Yes,
doubt
sir.
that it has been. I hope participants might have
Understood, sir.
understood to the possible extent, because
Yes.
whereas they have a little bit experience, they can otherwise even after their practice, surely they will get a benefit from this.
Yes.
Once again, thank you, sir, from my side for your sparing valuable time from your side. Now I
Yeah.
request Madam Radhika to propose vote of thanks for this session.
Good evening, one and all. It's my privilege to propose vote of thanks on third day afternoon session for 1 week online ISTE-STTP on machine learning application research challenges 2020. I would like to extend special thanks to Mr. Venkat sir for sharing us an enlightening knowledge regarding supervised learning, and in that linear regression algorithm has been demonstrated in a very good way where each and every participant have involved. And regarding Python, how we need to execute that algorithm by using Python. And yesterday, sir had given introduction regarding packages and those all. In the continuation of yesterday's session, we had seen linear regression algorithm today. And I hope the same will be continued tomorrow also, sir, with unsupervised learning. Every participant have gained a very good knowledge from this, sir. Thanks a lot, sir.
Yes, yeah, madam. Yeah, thank you.
Venkat
Thank
sir,
you.
Venkat sir.
Yes, sir. Janardhan, sir.
Sir, session is on Friday morning, sir, not tomorrow, sir.
Yeah, I'm sorry. Yeah, Friday morning. Yeah, exactly.
Yes, sir. Just because actually, my dear participants, actually, sir session is scheduled Friday afternoon due to some adjustment with Dr. Vadlamani Ravi Garu. We have changed Venkat sir session 6th morning. Friday morning. Tomorrow, first hour session will be by Dr. S. Vishwanath Raju, which is on artificial neural networks with real-time examples. Then tomorrow, second session will be by Dr. Ramakrishna A.G., Professor, Indian Institute of Science, Bangalore. Okay, again, very important lecture tomorrow afternoon, which will be by Dr. P. Krishna Reddy Garu, Professor, Data Science and Analytics Center at IIT Hyderabad. My dear participants, don't try to participate from here onwards, at least every one of you, without missing all these sessions. Every session is very important. We have very good resource persons. Hope every one of you are going to be utilize this to the maximum possible extent. Thank you, my dear participants. Thank you.
Yes.
We'll meet tomorrow morning.
Janardhan sir,